Hello everyone, this is Shivam Sharma, and today I'm going to teach you about conservative and non-conservative forces. Okay, so basically, what is a conservative force and what is a non-conservative force? I am going to define that first, and after that, I will give you just two examples, like which forces are conservative forces and which can't be conservative forces. Okay, so just first I'm going to describe what is conservative force. So conservative force, okay, I can teach in Hindi also. So conservative force, okay, I'm going to give you the basic definition first. Then, like, if the if the work done by the force is independent independent of the path. Okay, so this is the basic definition of a conservative force. So I'm going to define this. I'm going to describe this first. Okay, so let's take an example. If this is point A and this is point B, and if I have a force F, like let's say there's a block which is situated at this point, and if there is a block, and if I'm going to apply a force F on this block, and it will start move from A to B by following this path. Okay, so obviously this force had done some work on this block when it is like taking this block from A point to B point. Now, here's the case. If I just change the path, okay, if I just change the path like this, keeping the initial point and the final point same, but making the path different. So I will, if I just say this is path one, if I just say this is path two, and if I apply the same amount of force, so if it is a conservative force, then what will be done? Like if it is a conservative force, so work done by this force along path one is equals to work done by the same force along path 2. So if this criteria meets, the work done will comes out to be equal, irrespective of the path which the block is traveling. So then we can say that the force F is a conservative force. So in that case, we can say that the force is a conservative force. So I think this is the basic, and I think you guys got the point what I want to tell you. Okay, so this is the basic definition or the basic uh, terminology behind conservative force. So why do we need conservative force, and what exactly, like in nature there are a lot of kind of forces. So are these all conservative forces, or there is something which are not conservative forces? So there's some there are a lot of forces which are non-conservative forces. So I'm going to describe that too also. Okay, first the definition, and after that I will just tell you two examples of each. So what about non-conservative force? So it's just the opposite of the first one. So work done, if the work done by the force is dependent dependent of the path followed, path followed by the object. So in that case, keeping the same example above as we have mentioned, in that case, work done by the force along first is not equals to work done by the force along 2. So this is the basic difference between conservative and non-conservative forces. Okay, so I'm giving you one example of each so that the definition will be more clear to you. So first take an example of conservative force. So as we are already studying in our class 12, there is one force which is called electrostatic force. Okay, so okay, let me rub this. So first one is called electrostatic force, or you can say it as electric force, whatever you can call it. So let's take the symbol as F. So this is a conservative force. So this is the conservative force. And if I talk about friction, if I talk about friction or tension, like friction between the two surfaces and tension in the string. So these forces are considered as non-conservative forces. Okay, so these are non-conservative forces. So these are the basic example. Also in electrostatic force, you can write gravitational force, gravitational force, or gravity. It's not or, there is a difference between the two. Okay, so I will just tell you the difference between the two in a later time when I will just give the example. So these forces are also conservative forces. So these forces are conservative forces and these forces are non-conservative forces. So how, like, we have defined that these forces are conservative and non-conservative, it is only on the basis of the work done which like when these forces are applied on an object, and when the object moves from an initial position to the final position, then work done has to be done by these forces. And if the work done is irrelevant of the path keeping the initial and final position same, then we can consider that force to be a conservative force. Otherwise it's a non-conservative force. Okay, so let me just give you an example, like by drawing one or two scenarios. Okay, so let's take gravity. So gravity. Okay, so there are one or two, three terms which are like more or less similar to a normal person. Like when you study these things, so you always consider that the gravity and gravitational force are always the same. So I'm just giving you a brief difference between the two, the gravity and gravitational force. Okay, so gravitational force. What is gravitational force? So basically, there is a formula which in class 11th you must have studied, like G m1 m2 over r square. So this is the basic formula which you guys have studied in class 12, class 11. Okay, so this is called gravitational constant. This is the mass m1. Okay, let me just, I'm drawing one diagram. There's one diagram. So this is mass m1. This is mass m2, and this is the center to center distance r, and the gravitation constant, this is g, is gravitational constant. This is gravitational constant. And if I just talk about the force between the two, like this force is attractive force. Okay, so they both are attracting each other because of the gravitational force, and the value of the gravitational force comes out to be capital G m1 m2 over r square. So this is called a gravitational force. So it acts between any two masses in the universe. Okay, if there is a mass, then it will going to attract the other mass with this force, keeping all the variables like capital G. There is a value of this r, a distance between the two masses, and this m1 and m2, their individual masses. Okay, so this is called gravitational force. Okay, so it acts between the two bodies which are having masses m1 and m2. So what about gravity? So keeping a special case of this thing, keeping a special case of this thing. So what is that special case? So keeping the mass m1 as Earth. Okay. So if I just say if I'm on Earth, and there are a lot of objects which are on Earth, like every of us, like I'm also having some mass m. So if I just take like me as this point at this point, and if I'm having a mass small m, and Earth is having a mass capital M, so in that case, I've just named it differently, and I'm going to say the force between the earth and me, like the force with which this earth is going to attract me is called gravity. So Exactly, gravity is nothing but a gravitational force, but in a special case, where is the first mass is Earth, and the second mass can be anything which is on Earth or outside Earth. So it is like the first mass is constant and it is always Earth, and the force with which Earth is going to attract every other mass is going to calculate by the formula by the same formula where m1 will be replaced by capital M and small m and r square is the distance between these two masses. So this is gravity, and there's nothing. The formula is same, but the difference comes out to be like the first mass has to be Earth. Okay, so I think like you got the point with the difference between gravity and gravitational force. Okay, so now I'm just going to tell you like why gravity or gravitational force is considered as a conservative force. Okay, so let's just take a simple example. Okay, so this is a block, this is a ball which is having a mass m, and if it is from from the floor, okay, if I just take it as floor, if I just take it as floor, so the distance between this floor and the ball, initial distance is h, and if I just drop this ball, if I just drop this ball from this mass of having mass m from this height h. So I think obviously there is one force which you must know. Okay, let me just introduce that force also. That is called weight of the object, and it always acts towards the center of the earth. So and it is termed as mg, where m is the mass of this block and g is the acceleration due to gravity, which is in general 9.8 meter per second square, and then m is the mass of the object. Okay, keeping it as 5 kg or can be anything. So this mg is called the weight of the object, and this is nothing but the gravity. There's nothing but the gravity with which the object is being attracted by the earth when the distance is comparably small to the radius of earth. Okay, so if we are obviously we are very near to the center we are very near to the surface of the earth, so we can see that r is very very large as compared to h here, because r is something about 6400 kilometer. So these distances are not that much more, so we can say that mg is the gravity which is 9.8. Okay, so uh, now I'm going to calculate the work by this mg. So the basic formula for the work is force, displacement, and cos of theta. So this is the basic formula. Okay, in its vector form, it is also written as F dot D. So this is the basic, whereas F is the force which is acting on the object, and D is the displacement of the object, and theta is the angle between the force and the displacement. So in this case, as you can see that when the object moves from up to down, so this is the direction of the motion. And also we can see that mg is the gravity which is going to be which earth is going to act on this object. So the direction of this mg is also downwards, and also the motion or the displacement of this object is in downward direction. So the angle between the two is zero in this case. So what we will write in place of force, the force here is mass times gravity, and displacement, we can see that if the object will move from this place to this place, it will be going to cover h. So this is the displacement we have, and there is third term which is called cos of zero, because the angle between the two is zero here. So cos of zero is 1. So the work done which I will get is mgh, and this is the total work done which this gravity will act or will do on this mass m. Okay, so what about this? Now what we will do this? What we will be going to use? Where will be going to use it? Okay, so I have already told you, like if I just change the path of this motion, keeping the initial and the final point same. So will I be able to get the same amount of work done by the mg? So this is the scenario now. So okay, I'm just drawing the diagram again. So this is height h. Okay, and in place of in its place, I'm now uh, making one another diagram. So this is another diagram. Okay, so here also the center point is same, and the height is also h. Okay, I'm just only telling you like this. This is the height h, and also the ball is now at this place. Now it is going to cover the same vertical direction h, or the same amount of distance. No, not the same amount of distance. Like the initial and the final point are the same, because initially it is having at h at height h, and finally it will be going to come on the floor. Now the question comes: if the same ball moves in the along this path, initially it is moving from this path. Now it is going to cover this distance. Will the work done be equals to mgh? Okay, so now let me just take there are some forces are there. So initially there is mg which is going to act downwards. You can see that it is going to be in this direction. Now, as we have already covered, there's like resolu we can divide this. This is the formula. So this is the theta. This is the theta. So there is a resolution. So we can say it as when. Okay, I'm just going to draw this diagram. I don't know like whether you know this thing or not. So that's why I'm just going to tell you this thing, because if you don't know, you won't be able to understand. Okay, if the forces are making an angle like this, so this is called resolution, or this is called like when there is a force, so we can just resolve the force into its horizontal and perpendicular direction. So this force is going to the projection of this force along the horizontal direction is f of cos theta, and in its perpendicular direction the projection is called f of sine theta. So this force f is now converted into f of sine theta plus f of cos theta. So we can write it as like this: f of cos theta I cap plus f of sine theta j cap. So you can see that now the force which is in an arbitrary direction, now it is converted into horizontal and vertical direction. Okay, so in a similar way I'm going to write mg. So there is theta here, so this theta is comes out from this theta. So that is basic geometry. So mg is going to be mg cos of theta here, and in its perpendicular direction is mg of sine theta, like this. Now we can see that as the object is moving along this direction, as the object is moving along this direction, so there is no displacement along this direction. So we can see that this mg of cos theta, so this is one force and this is also one force. So the two forces are there. So we will be going to calculate work done due to individual uh, individual forces, and we will just add them. Okay, so work done due to mg cos theta. First, we will calculate this. So as we can see that the force is mg cos theta here, and displacement here is. So we can see that as the object moves from this point to this point, and if we just use the sine of theta here, like this is a triangle, so we can write it like this: sine of theta is p over h. So in this case, this is height. Height is our h. Height is our perpendicular in this case, and hypotenuse is the displacement which we need. Okay, so this is the displacement which we need, which this ball will cover. So this is the displacement. Now, if I want to calculate, if I need this displacement, then I will have to put it here. So it will be going to be converted like this: d is h over sine theta, like this. So this is the displacement which this ball will cover as it moves from first point to the initial point to the final point. So I have to write h over sine theta here in this case. And it's like this. Now, in a similar way, like a force and displacement, and the third one is cos of theta. So in this case, what is the angle? So as you can see that the force is in this direction and the displacement is in this direction. So we can see that the angle between the force and the displacement is 90 degree. So in this case, this is cos of 90, and whatever is written here, it's going to be zero because cos of 90 is zero. So in the first case, work done due to mg of cos theta is 0. So we can see that the work done due to the mg of cos theta is 0. So for the second case, if I just calculate for mg of sine theta, so work done due to mg of sine theta is what? Now in a similar way, I have to write force, which is mg of sine theta in this case, and the displacement. So I have already calculated the displacement. So it is which is h of sine theta, h over sine theta, and the angle between the two. Now in this case, we can see that the force is in this direction, and also the displacement is in along the same direction. So we can say that cos of 0. We can say that the force and displacement are in the same direction. So in this case, you can see that this sine theta will cancel out by this sine theta, and what we will get mg or multiplied with the h. So this is the work done which this mg of sin theta will be going to do on the ball when it covers a when it covers a displacement which is h over sin theta. Now if we will add the two, because the work done due to the mg cos theta is 0, so the total work done will be equals to what? The total work done will be equals to mg over h, sorry, mg h. So we can see that in the two cases, I have taken the first one a straight line, and in the second case, I have taken the second part as a slant height. In the two cases, the work done is coming out to be equal. So this is the work done first, and this is the work done second. So in this case also, the work done is mgh. So we can see that the mg is a conservative force, and it is irrelevant of the path which you are traveling. Keeping the initial and final position same, you can see that the work done is coming out to be equal. And also we can go for the third diagram, third case also. If you just need the clarification, okay, I'm just also giving you one more example. Like if you just take like this, okay, let's take it as a staircase. Okay, in this case also, if I just use h as the height, and keeping the ball at this point, and this is the initial point and this is the final point, and let's take this as x and this as y. Okay, so you can see that in this case also, if you just calculate the work done, then also you will be going to get the work done as mgh. Okay, so let me just help you with this. Okay, as you can see that initially when the ball moves in this direction like this, and also you know that the mg here is like this. Okay, I'm not going to calculate the whole of the thing here, because I'm it's for you guys to just to understand the basic. I have already given two examples. I'm going to tell you the third one only just to clarify the things in a more clearer way. Okay, so mg in this case in the vertical direction, and you can see that initially the displacement is in this direction, and there is the angle between this. The angle is 90-degree here. So if you just talk about this as w1, so this is mg with the multiplication of some distance which is y, but with cos of 90. So cos of 90 is going to be equals to 0. So if this is w1, this is w2, this is w3, this is w4, sorry, this is w4, this is w5, this is w6, this is W7, this is W8. So you can see that W1, W3, W5, W7 all will be going to be 0, because in that case the cos of 90 is there. So W1 is equals to W3 is equals to W5 is equals to W7 will all be going to 0. Okay, because the angle between the displacement and the force in that case is 0. Sorry, is 90-degree, and the result will be 0. Now let's talk about W2. You can see that in that case, if when the ball is moving from this point to this point, so it is going to cover a distance which is x, and also the mg is there. So if you just take the force as mg, and displacement in this case is x, and the angle is what, like mg is downwards, and also the displacement is downwards. So in this case also the cos 0 is there. So cos 0 is 1, so you will be going to get mgx as w2. And also if you just calculate w4, you can see that if you just calculate w4, you will be going to get mgx, and for same w6 you will be going to get mgx. So and also for w8 you will be going to get mgx. So what will be the total work done? So the total work done when the ball goes from this position to this position is the summation of all of this. And you can see that the W1, W3, W5, W7 all are equals to 0. So what you will going to get? This is 4 mgx. This is the total work done which you will going to get. And if you just write it like this, and you can see that if I just take this as x, this as x, this as x, and this as x. So this 4x is equals to what? This 4x is equals to h. So in that case also, this is the total work done which you are getting. So it is also one example in which you can see that uh, if keeping the initial and the final position same, if you are taking some another path, then the work done by the mg is calculated as mgh. So we can say that mg is a conservative force. And what mg is? Okay, so I'm just going to give you a brief idea what the mg is. So we say it as weight of the object, and it is written as g. But if you just open this small g, so this is acceleration due to gravity, which is nothing but like this. So this is the mass of earth, this is the radius of earth, this is the gravitational constant. These all are constants. For if you just put the value of all these, you will get 9.8, and this m is the mass of this ball. So this weight is nothing but it is the gravity, because if you just rearrange this, so it will be like this. It will be like this. So keeping the h is very small here, because I've already told you like this is the distance which is very less as compared to the radius of the earth. So the weight is coming out to be g mm over r square, and this is nothing but gravity. So we have talked about gravity as a conservative force, and we have already shown it. Okay, so I think the things are clear to you, and I hope now you will be going to get a lot clear, more claration, more clear concept about conservative force. There are lot of properties of conservative force, like the force. Okay, so I will just give all that thing in the later lectures. I will be going to give you a more detailed idea about like how to calculate the del cross F, and if the del cross F is 0, then we can also say that this force is a conservative force. These are some properties of a conservative force. Okay, we will not going to give the elaborated idea of this all in one lecture only, because this that will be more complex to you. Okay, so now I'm just moving on for non-conservative forces. So non-conservative forces are what? I've already told you. I'm only giving you one example of that. Okay, if I just push a block F, and if it moves from A point to B point like this, and we can see that in this case there is a friction which is going to act on this block. There is a friction which is going to act on this block, and let's say that friction is 1 Newton. Okay, I'm just giving you one example, and the distance which it is going to cover is distance d is called like 10 meter. So in this case, you can see that initial is this. This is the first position. This is the second position. This is the initial position. This is the second position. Now in this case, if you just calculate the work done due to the friction, I'm only calculating the work done due to the friction. So what you will write first the friction here with the multiplied with the displacement and with angle theta. So in this case, the friction is 1 Newton. And if you just multiply the displacement as 10 meter, and what is the angle here? Because as you can see that the displacement is in this direction, and but the friction acts opposite to the direction of motion. So here is cos 180 degree. So cos 180 is minus 1. So you can see that this minus 10 joule of work done comes out. So this is due to the friction. Now, as I've already told you, if I just change the path, keeping initial and final point same. So if I just move now the block along this path like this, so in that case, intuitively, you don't need to calculate the stuff in this case. Intuitively, you can see that the friction is going to act in other directions because when the object is moving in this direction, the friction is acting in this direction. When the object is moving in this direction, the friction is going to act in this direction. When the object is moving in this direction, the friction is going to act in this direction. So you don't really need to calculate the total work done due to the friction along this path because you won't be able to because the angle is continuously changing. But you can answer this example intuitively also. And the reason is when it is moving from A point to B point, it is going to cover a more distance. That is the foremost thing. Like this is D here and this is D here. Or it is going to cover more distance here. And also the friction direction is also changing. So you can see that anyway it is not going to be zero. This comes out to be zero only in one case when there is an angle which is cos of 90. So in any of the case, you won't be able to calculate the angle as cos of 90 because it is always going to act opposite to the direction of motion. In friction, it is the property like it always opposes the relative motion. So that is why the friction and the displacement direction has like they will make angle of 180-degree with each other. And also the theta is not zero, so that's why the work done will not be equals to zero. Also you can see that the distance is more in this case, so work done by the friction along second path, work done by the friction along second path will be more as compared to the work done by the friction along the straighter one because the displacement is more. Theta will not be equals to zero and force is same as I've already told you, like the force is like keeping it as 1 Newton. So we can see that the friction is not going to give us the same amount of work keeping the initial and the final position same. And if it is so in the nature, if it is so, then you can see like why we need petrol, why we need diesel, why we need energy to run cars, to run bikes. That the reason is very simple because friction is there and friction is going to oppose the motion and it is going to cost our energy to move against the friction. So if I move more distance, that is why we are going to use more energy. So this is the basic difference between the conservative and non-conservative forces. I hope you got the point. Now, I hope you got the point. Like, if you guys have any kind of doubt, like we will be going to cover this in the later sections. Obviously, we will just take a 10 minutes Q&A after this. Okay, so there is one basic difference, basic line which is going to help you to determine whether a force is conservative force or not. So central forces are conservative forces. So this is one basic thing which you can use. So central forces are conservative forces. So I am going to write all central forces. But the reciprocal is not true. This is also you have to keep in mind. But the reciprocal of the above is not true. Okay. What it means? It means like all conservative forces are not need to be central forces. So this is the reciprocal. So it is not going to be true. But what about the first one? All central forces are conservative forces. What do you mean by a central force? So a central force is nothing but if an object is moving like along this path, and if it is facing a force which is like this, so if it is moving along this path, and if you just elongate, or you can say that if you can just draw it further, if you just extend the direction of force, and if all the direction are meeting at the same point, so we can say that this force is central force. And actually it is nothing but it is like a circle with a center, and the direction of force is always towards the center. So we can say that this force is a conservative force in that case. So what about gravity? How gravity is doing the thing? So it is just you can see by the example, like if this is Earth and the object is there, so obviously the gravity will always be in this direction. If the object is at this place, so gravity will be like this. If the object is at this place, so gravity will be like this. If the object is at that place, so the gravity will be like. So you can see that the gravity is always acting towards the center of the Earth, and also for the same for the gravitational force. So that is why gravity is one of the central force and which is a conservative force. But it obviously it is not the case with non-central forces. If the forces are non-central in nature, they are not conservative. So this is one of the very major difference. So you can keep this in mind and you can just differentiate between the two by taking this as an one point. There is also one point which is which you can mathematically use to calculate like whether a force is conservative or not. So this is one formula, or you can write it as equation. What it is like there is one called divergence. Sorry, this is called divergence gradient, and this is called curl. So this is curl. So the curl of any force is equals to zero, then that force is called conservative force. What does it means? I'm not going to go into the details, but I'm only going to give you the intuitive explanation of this thing because this class is only for you to understand what is a conservative force and a non-conservative force. So I'm keeping this in mind. I'm just only going to give you the what is like why we need curl and why the curl of a conservative force is coming out to be zero. So you can see that there is electrostatic field. Okay, so this is plus q. So for plus q, you always draw like this. What it is electric field, or it is kind electric field lines. So these are electric field lines, and the along this direction, obviously, when a charge comes up, this if it is a positive charge, it will be going to experience a force in this direction, and if it is a negative charge, it will be going to experience a force in this direction, which is the attractive force, and this is the repulsive force. So what does it determine? Determines like these forces or these lines are not going to curl like this. It is not going to curl like this. So if you just calculate the curl of this thing, okay. So let me just finish this thing. Okay, this chapter this lecture contains this much only, and we will be going to cover the next thing in the later section. Okay, so till then, see you guys. Okay, we will going to meet in the next class. Thank you very much.